If you are interested in my videos, please like and share the videos and subscribe my channel if you have not already subscribed. We now discuss the solution of a problem from the section Complex Analysis, and this question has appeared in the CSIR National Eligibility Test held in December 2023. The question is related to the contour integral. This question is from the part C. It is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 704081. This question is suitable for the aspirants of JL, DL, TS Set, AP Set, IIT JAM and GATE examinations. The given question is for an integer k, consider the contour integral I suffix k is equal to integral taken round the unit circle mod z is equal to 1 of the function e power z by z power k with respect to z. So, for an integer k, we have the contour integral denoted by ik is equal to integral taken round mod z is equal to 1 of the function e power z by z power k with respect to z. Which of the following statements are true? We are given 4 options. Option 1, ik is 0 for every integer k. Option 2, ik is not equal to 0 if k greater than or equal to 1. Option 3, mod ik less than or equal to mod of ik plus 1 for every integer k. Option 4, limit k tends to infinity of mod ik is equal to infinity. Let's now discuss the solution of the problem in detail. We have the contour integral ik is equal to integral taken round mod z is equal to 1 of e power z by z power k with respect to z, where k belongs to the set of integers. Let's now discuss the solution of the problem in detail. We have ik, that is the integral taken round mod z is equal to 1 e power z by z power k with respect to z, where k belongs to the set of integers. We note that e power z is an entire function. We consider two cases. Case 1, let k belongs to z minus union the singleton 0. That is, k belongs to the set of non-positive integers. Right. So, let k is equal to minus m. Then what will be m? K is negative and 0. Therefore, minus m, where m belongs to the set of positive integers union 0. That is, it is the set of non-negative integers. Right. Now, then ik is equal to integral taken round mod z is equal to 1 e power z by z power k with respect to z is equal to integral taken round mod z is equal to 1 e power z by z power k, that is z power minus m dz. And now this will be equal to integral taken round mod z is equal to 1 z power m into e power z dz, where m is a positive integer and union the singleton 0. Right. M belongs to z plus union singleton 0. Now, for these values of m belongs to z plus union the singleton 0. Z power m is a polynomial, and it will be analytic everywhere, therefore it's an entire function. This is an entire function, e power z is an entire function, the product is an entire function, therefore integral taken around mod z is equal to 1 of this entire function dz is 0. We apply the famous Cauchy's theorem. That is, if fz is analytic in a simply connected domain D, the simply connected domain is the whole of the complex plane, and C is the closed contour, that is mod z is equal to 1 lying in D, then the integral taken around C fz dz is equal to 0. We apply this and we get this 0. We use Cauchy's theorem because z power m into e to the power of z is an entire function. Right. So we have evaluated ik when k belongs to z minus union the singleton 0. So the value of the integral, the contour integral ik is 0. And this is true for all k belongs to z minus union singleton 0. Now we now go to the next slide and discuss about the next case. Right, we have done the case 1 and we go for the case 2. Let k belongs to z plus, the set of positive integers. Now ik will be integral taken around mod z is equal to 1 e power z by z power k dz, and this is equal to integral taken around mod z is equal to 1 f of z by z power k dz, where f of z is e power z. Agreed. By looking at this one, we remember the famous Cauchy's integral formula for higher derivatives. So that is precisely the generalized Cauchy's integral formula. So this formula says let fz be analytic in a simply connected domain containing the simple closed contour C. The C is mod z is equal to 1. It is analytic, and so inside and on this is the simply connected domain, and f of z is e power z is an entire function. And then this generalized Cauchy's integral formula tells you then f of z has derivatives of all orders at each point z naught inside C. At every point z naught inside C, f of z has derivatives of all orders. Right. And the value of the nth derivative at z naught, where z naught is any point inside C, is given by the Cauchy's integral formula for higher derivatives n factorial by 2 pi I integral taken around C f z by z minus z naught to the power of n plus 1 with respect to z. In our case, f of z is e power z and z naught is 0, n plus 1 is k. Then n will be k minus 1. Then this integral will be 2 pi I by k minus 1 factorial into k minus 1th derivative of f at 0, because in our case z naught is 0. So what is f of z? E power z. If you differentiate any number of times, it will be e power z only. So the k minus 1th derivative of e power z is e power z only, to be evaluated z is equal to 0. So that is e power z, z is equal to 0, that is e power 0, that is 1. So ik when k belongs to z plus is 2 pi I by k minus 1 factorial. So that is our ik in the second case when k belongs to z plus. Agreed. We move to the next slide for the further discussion of the options. We have ik is 0 when k belongs to z minus union 0, and ik gives 2 pi I by k minus 1 factorial for all k belongs to set of positive integers. Agreed. Now let's call the options one after the other. So option 1, ik is 0 for every integer k. Ik is 0 only for k belongs to z minus union 0. So for k belongs to z plus, it gives 2 pi I by k minus 1 factorial, which is not equal to 0. Thus, ik is 0 for every integer k is false. Note that ik is not 0 for any positive integer k. For any positive integer k, it will give you 2 pi I by k minus 1 factorial, which is not equal to 0. So thus, the option 1 is not true. Right. And option 2, ik not equal to 0 when k greater than or equal to 1. When k greater than or equal to 1 means k belongs to the set of positive integers. Then ik is 2 pi I by k minus 1 factorial, which is not equal to 0. Therefore, our option 2 is true. Ik is 2 pi I by k minus 1 factorial is not 0 if k greater than or equal to 1. That means k belongs to the set of positive integers. Therefore, our option 2 is true. Now, option 3 says mod ik less than or equal to mod of ik plus 1 for every integer k. For this, first of all, let us see what is mod ik. So, for k belongs to z plus, we consider this. Mod ik is mod of 2 pi I by k minus 1 factorial, and mod I is equal to 1, that is equal to 2 pi by k minus 1 factorial. So, mod of ik plus 1 will be 2 pi by k factorial. So, for k belongs to z plus, mod ik plus 1 is strictly less than mod ik for all k belongs to z plus. This is completely opposite to this. So, therefore, for every integer k, it said, and for k belongs to z plus, mod ik plus 1 less than mod ik for all k belongs to z plus. Therefore, option 3 is not true. So, limit k tends to infinity of mod ik. Mod ik is 2 pi by k minus 1 factorial. As k tends to infinity, 2 pi by k minus 1 factorial tends to 0. But here it is given infinity. Therefore, option 4 is also not true. So, limit k tends to infinity of mod ik is limit k tends to infinity of 2 pi by k minus 1 factorial, and that will be 0, but it is given to be infinity. Therefore, the option 4 is also not true. So, the answer to this question is option 2. So, that is the detailed discussion of the solution of the problem, which is related to the contour integral from the section complex analysis. It will definitely be a simple and straightforward question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.